Okay, so new practice for energy chapter. You have your calculator ready. Give me the calculator as well. Okay, this is file energy IEL file. This one energy IEL practice file. Question number 1. I don't know from which question bank is it from. Okay, some of you were complaining that I did not write the years over here because these were randomly generated questions, so I can't do anything about it. Okay. Okay, so in 1865, in his book From the Earth to the Moon, the writer Jules Verne wrote about sending a man to the moon. Okay. Now, in order to escape the Earth's gravitational field, Verne proposed firing a capsule, okay, from the cannon at a length 220 meter. Imagine this was a 220 meter. It's double of our school football field, our school field. Okay, double, as shown in this illustration from this book. Okay. So now the velocity of the capsule at the end of the cannon was estimated to be 11 kilometers per second. So এখানে 12 সব দিছে, it goes, and when it goes it should travel at around 11 kilometers per second. Okay, actually this was the thing I saw in one of the animation, old animation. It's like when you throw it, it just at very high speed, it just goes like this, and then it will get attracted to our Earth's gravity, and it can go just round and round around the Earth. Understood? So that was the whole, for them those days cannon was the fastest thing, not like rocket. They couldn't even imagine rocket because they didn't see rockets. That's the reason. So for them cannon was the fastest thing, you know. Okay, you can see how far our world has come into. Now calculate the acceleration of the capsule through the cannon. So this is very easy. I think it's going to be s equals to v square is equal to u square plus 2as. Yeah. So v final velocity v square is equal to u square plus 2as. Final velocity কত? 11 kilometer মানে 11,000 square. U is 0 square plus 2a. A কত? 9.81. No, acceleration is the one we are supposed to find here. Yeah, 2as, and s is 220 meter. Everybody did the same thing, na? And a we don't know. Yeah. So what was the a you guys got? Huh? 275,000. Holy moly. Okay. 275,000 key meter per second square. Is this understood, everyone? Till here, everyone is clear, right? I'm pretty sure. Now, it can be assumed. Now, this is a very important part. It can be assumed that only 50% of the energy supplied by the gunpowder, money, it is only 50% efficient. Okay, so if you use 1 kg, you are using, technically you are using only 0.5 kg, because baki 0.5 kg is a waste. Okay, in the cannon would have transferred to the capsule. Determine the mass of gunpowder that would have been required to obtain maximum speed of 11 meter per second. Okay, how would you do this? Now 11 meter per second. Now what are we trying to do? We are trying to convert those gunpowder energy inside the gunpowder to kinetic energy. Yeah, kinetic energy. Now first thing first, you need to find is what is the kinetic energy required for that capsule. Okay, to go at a speed of 11 kilometer per second. So half. Okay, what is the mass they gave us? Did they give us any mass over here? Huh? Down, down, down. Yes, they did. So mass of the capsule is 1,500 half m v square, 11,000 square. Karo. Kinetic energy is half mv square. Karo. Tell me what is the answer you guys are getting? How much is it, guys? সবাই বলো আমাকে আস্তে ধীরে। 9.075 into 10 raised to 10 joules. Okay, now they are calculating everything in megajoules. Okay, okay, that's okay, it's not a big deal, but those who are online, you guys understood what I'm doing here? Like, you understood the calculation? Everyone? Like, and you guys got the calculation in your calculator, exactly the same calculation, everyone? Okay, please, I would like to hear voice as well. Kainat, yes. Mariam? Acha, okay. Mehak, Butseta?
Yeah.
Cool. Now, most probably next Sunday, next Saturday, there is going to be a test on energy chapter. Okay. Fluid chapter, so I send it to everyone. I did not send your parents yet. Otherwise, everyone I send it. Okay, fine. So now, how much gunpowder should he burn? Energy released from burn gunpowder. Can you see? Look at this. What does this mean? This means 3 megajoules, meaning 3 into 10 to the power 6 joules of energy is getting 3 into 10 to the power 6 joules of energy is getting converted if you burn 1 kg. But the problem is it's not 1 kg. Okay. If you burn 1 kg, you are not getting this thing, 3 megajoules. You are getting how much? You are getting only what? 1.5. Why? Because your gunpowder is only what? 50% efficient. That is the reason. So 1 kg, you are getting 1.5 10 raised to 6 joules. So therefore, for 9.075 10 raised to 10 joules, how much kg is left? Did you guys get it, everyone? Do this in cross multiplication and give me the powder. What is the one thing I did here? I made my energy to be 50%. Okay, I'll pause the recording. You guys finish this calculation. 6.05 into 10 raised to 16. 16 kg of gunpowder is required. Now let me see the mark scheme of this. Okay. And for modern humans, this is nothing right now. 6.05. No, something is wrong. 10 to the power 4 kg they got. 9.05 10. What?
This is which they did is correct now. Someone told you the wrong answer.
Wrong answer on what?
This one is wrong now.
Okay, wait, don't shout. It's okay, calm down. Okay, she's saying this is wrong. Do the calculation again.
It's
Tell me,
6.5. 6.5 into 10 raised to 4.
6.5 into 10 raised to 4 kg is the answer. 6.5 into 10 raised to 4 kg equals to answer. Okay. Did you understand your mistake where you made it? I'll pause the recording. Just check your mistake. No. In order to land safely on the surface of the moon, Verne suggested that gases could be ejected from the capsule to reduce its speed. You guys know this. I don't think I need to revise it, no? I don't think I need to revise this. This is pretty easy. Newton's third law. Every action has equal and opposite reaction. So now I'm not doing this. Okay. How many of you have doubt in this question number 2? Anybody wants a revision in question number 2? I'll pause recording. So let's resume the class. Question number 2. Now they said exercise on a bicycle has display shown. So this is the distance he has traveled. Most probably this is in kilometer. This is the resistive force. This is in watts. This is the time. And this is the speed at which he is moving. Okay, so all these informations are given over here. So the equivalent motion of a bicycle is displayed as a speed and distance travel. Guys, check. One of the quantities being displaced is expressed as watts. Okay. State the name of this quantity. Power. Power is said in watts. Okay. The bicycle provides a resistance force against the cyclist. The units of this resistance force is Newton. Okay. The unit of speed is kilometer per hour. Okay. The unit of the speed is kilometer per hour. The unit is Newton. So this is in Newton. What resistance? This is in Newton. And speed is kilometer per hour. This is kilometer per hour. Okay. Now what is the distance in? Is the distance in kilometers? Did they say that? Show that the value displayed for the resistance, force, and the speed are consistent with the value displayed as watts. Now, how would I do this? Force into distance by time taken is power, na? Force into distance by time taken is power, right? And or force into velocity is power. Yeah, what did they say? The speed. Show the, okay. Force into speed. Okay, তুমি একটা কাজ করো, তোমরা একটা কাজ করো, কিলোমিটার পার আওয়ার কে কি মিটার পার সেকেন্ডে কনভার্ট করো, এটাকে কি 28 কিলোমিটার পার আওয়ার কে, then multiplied by 16 Newton, because force into distance is what? Power. Do that and let me know whether you're getting the question. Kainat, you told me that you have doubts. Please, 28 kilometer per hour convert it to meter per second and multiply it by 16, because force into velocity is power. Remember that question. Okay, so let me help you guys with this question as well. You guys were able to do this anyway. So what did I say? Convert 28 kilometer divide by 28 kilometer per second. Per এখন সেকেন্ডের জন্য 3600 করো, cancel 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 cancel. Just let me know what is 280 divided by 36 in your calculator. Check 280 divided by 36, it is 7.78. It is 7.78. I do it this way all the time. Okay, meter per second. So power is equal to, and please in the examination break, like last time when you guys were giving fluid test to me, some of you were getting 1-2 marks. Why? You guys wrote formulas correctly. You guys wrote step by step. You guys didn't do everything together. If you guys did do everything step by step, I could give you marks, because they said if this is seen, 1 mark, if this is seen, 1 mark. So step by step karo, at least you are not losing all the marks. Remember that trick. It's somewhere over there. I don't know. I'll check. So now you have, what is it? What is this, by the way? Power is equal to force into velocity. What is the force we are getting? 16. What is the force and velocity koto? 7.78. Is this clear, everyone? Okay, and how much you guys getting in this calculator? 16 into 7.78, 16 into answer, it is 124.4, which is correct. 124.4. So consistent asset. Now the time on the display is given in minutes and the distance on the display is given in kilometers. Okay, so this is in kilometer, etake meter convert korte hobe. This is in minutes, etake second e convert korte hobe. Now you have to say, okay, deduce whether the speed given on the display is instantaneous or an average. You have to check that is speed ta instantaneous naki average. Okay, so let's find the average velocity first. Okay, but before that I need to convert my distance k. See, this is also you're getting some marks over here. You have to write it, don't do the whole thing together. 6.843 6.843 multiplied by 1000. 6.843 multiplied by what? 1000. How much is it? 6.843 multiplied by 1000 jodi kori 6843 meter. 6843 meter. Now let's talk about the time. Step by step like 13 minutes bolche na, time is 13 minutes. So call the 13 into 60, 13 into 60, 780. Clear? Shoy buchcho eta 780. Now 780 key seconds. What is this? Meter. Okay, so now let's find the average velocity. So average velocity is distance traveled by time taken. Yeah, so distance 6843 divided by 684 divided by 780. How much is it? 8.77. 8.77 meter per second. But here it is given 28 meter per second. This no 28 now. 7.78. Here it is giving 7.78. So it's an instantaneous speed. It is not an average speed. মানে ওই টাইমের মধ্যে ওর স্পিড কত ছিল, that guy. Okay, so this is, they are not matching. So it's an instantaneous speed. Okay, so let's try with the second one. What they said, 31.6 kilometer per hour. Okay, I did it in meter per second. It's okay. Must be instantaneous with the numerical comparison calculated display values. Okay, so 8.8 আর উপরে তো স্পিড তো 7.78 আমার কাছে আছে। Fine then, done. So this is also clear. Now question number 3, anybody could figure it out? Question number 3 answer key A B C D ke bolte pare. I'll pause the recording. So some of you guys told me the answer for this is is what? C. Now none of you guys can actually tell me why is it C. So what is the situation? Let me read the question. A ball is dropped, okay, and bounces 3 times before being caught. Okay, the following graph shows how the gravitational potential energy E-grav of the ball varies with time. Clear? Okay, so now you know each time it is bouncing, okay, the energy is lost to the surrounding. So even your total energy is lost to the surrounding as well. So overall your total energy also should decrease only when it is bouncing. Otherwise total energy is always constant only during bounce. Now A could be the answer, but the problem it is not bouncing, it is at maximum point. So this is wrong. See, at bouncing the total energy decreases, the total energy remains constant. So this is wrong. Total energy remains constant. I understand, but as you can see the energy is decreasing overall anyway, so your total energy also should decrease accordingly. So C is the only answer. Why? While bouncing some energy is lost to the surrounding, that is the reason. So your total energy is also decreasing. Okay, now let's talk about this one. Okay, you guys will do this on your own and tell me now. Okay, so let's try this. Question number 4. A man at a gym lifted a 150 Newton weight through the height of 2.1 meters. So he did this 36 times. So in 36 times, how much energy did he gain? So you know energy is mgh, right? You guys know energy is mgh. Now mg is the force over here. Mg is the force, 150 Newton weight, right? So mg jagah we 150 likhbo. Koto height 2.1. And how much time did he repeat it for? 36 times. And for how long did he do it? For 122 seconds. Now that will give you B as the answer. The power output. That's what they said. The power, average power output. Now question number 5. Okay. Now the concept with the question number 5 is, I think it has a bit of material chapter in it, right? Which question has material in it, by the way? Here, all of them, or maybe some of them. Okay, I'll see. Yeah, some of you did materials with me, some of you didn't. So if it has a material concept, I'm going to skip it. Okay, I have to do it in next class, or maybe I will do it. Maybe I'll do it. Okay, let's see. In the sport pole vaulting, a long flexible pole is used to lift the athlete up over a crossbar as shown in the diagram. Okay, so as shown in the diagram, you have pole. Okay, you can see that what is going on over here. It's self-explanatory over here. The athlete runs down the runway at a high speed, and the places at the end of the pole in the vault becomes pole in the vault box. My bad. The pole bends and then straightens. Okay, moving the athlete upward. At maximum height, the athlete lets go of the pole. Fine, you must have seen many videos like this for Olympics and sports and all. Explain how using the pole enables the athletes to reach a greater height. So if you're using the pole, you can reach a greater height than jumping. So jumping, now using the pole is better than jumping. Now I'll pause the recording. Let's discuss this answer. You guys tell me why. Resume recording. Okay, so we discussed the answers, and when we discussed the answers, we found this is what for 3 marks we are supposed to write. So this guy is running, right? When he's running, he has a kinetic energy. Okay, all this kinetic energy gets converted to elastic potential energy over here. Okay, and that elastic potential energy gets converted to gravitational potential energy when your pole is becoming straight. Now the next answer is supposed to write the pole is much more efficient in converting elastic potential energy to gravitational potential energy than the knee itself. Okay, I hope everything is clear. I hope everyone online understood. Now An athlete reaches a maximum speed of 9.4. So you know how much kinetic energy he has. So hint, he has reached a maximum speed. So you know how much kinetic energy he has. Before placing the pole in the vault box, okay, you may neglect frictional force and any work done by athlete's muscle after the pole enters the vault box. The athlete has a horizontal velocity of this much and a maximum height of this much. Okay, calculate the maximum possible change in height of the athlete's center of gravity. Now, I want each one of you think about it. Okay, let me give you guys the hint. First of all, they gave you that horizontal velocity, that 1.1. What does it mean? It means all the kinetic energy did not get converted to gravitational potential energy. Because why? There is some kinetic energy still left. Okay, so all of them did not convert. That is one hint. Initial kinetic energy is known to you. You can find final kinetic energy. You can find the difference will get converted to gravitational potential energy. By doing MGH, try to find the how much height did he go. Okay, I'll pause the recording. Do it. So let me resume the recording of this. Okay, so this one I taught you guys. Bro can't do. I sent a file in a group. I showed you the solution over there. I showed you the solution over there. Dekho. Bottom when he was running, he had a kinetic velocity, kinetic energy. What is it? He had a speed of 9.4. So let's say kinetic energy before. What are you doing? Let's see kinetic energy before. It's half m. M is m because the mass is not given to us. V square, 9.4 square. Okay. What is the kinetic energy afterwards? His kinetic energy after. Okay, so that is at the top. His kinetic energy is what? Again, half m v square. Okay? And what is the gravitational potential energy after? That is m g h. H I don't know. So you know the kinetic energy before. The kinetic energy before is equal to the kinetic energy after. Okay, because not all the kinetic energy before got converted to gravitational potential energy. The rest of them got converted to gravitational potential energy. Rafsan, Butsa, Akon. Now your m is common, so your m gets cancelled. Do this in calculator, minus it with this, and divide it by 9.81. You will get your answer. I'll pause the recording. You should get around 4.44 meter or something like that. Please let me know, Rafsan. So if you do whatever I said, answer should be 4.4. So this is done. Now, then they said spring constant. Now I'm not doing this. Okay, it's a 5 marks question. I should do it later on. Please do remind me to do all this question later on. Okay, once I do material chapters again with you all. Okay, so let's go to the next question. Let me find the next concept. Yeah, this question number 6. Okay, so I'll zoom it out a bit. Figure this out on your own. Okay, now. Okay, so the answer here is B, PQ, because if you see the line, look at the bottom part, it was touching the ground, na? So it went this height, and P and Q has the same this thing, though P is bigger, but look at the bottom part, it's almost the same. So P and Q, okay, has went the same height, so their change in energy is also same. So therefore P and Q is the answer because they have most change in energy, gravitational potential energy. Okay, so now let's find the next. These things I think you guys can do on your own. Halfway, what is the kinetic energy? Okay, try to figure out question number 9. I'm not doing all of them. I'm doing only some of them. যেগুলো আমি মিস করতেছি ওগুলো তোমরা হোমওয়ার্কে করে আসো. Question number 9, please do it. I'll pause the recording. Try. Okay, so you guys were able to do this question. Halfway to the ground, money, your H has been halved. So your energy also, your gravitational potential energy is halved. Your kinetic energy is also halved only. Okay, so now treadmill may be used in gym to increase whatever. Treadmills. Okay, treadmills may be used in gyms to increase the difficulty of trainings. Okay, training, the gradient of the treadmill can be increased. Can you see? Usually flat thake. If you want more challenging, you can just make it like this. Okay, so a person on a treadmill warms up by running a constant speed of 2.5 meter per second. Okay,
with a treadmill horizontal, okay, treadmill, okay, he then sets the treadmill to an angle of 3 degrees to the horizontal, okay, and continues to run at the same speed. Okay. Calculate the additional power that his leg would have to supply when running for how many minutes? 10 minutes. Okay. His mass is 80 kg. I would suggest you guys can use M1 slope equations over it if you want to. If you want to, you guys know his velocity. You guys can find its length very easily. Force into distance divided by time. Force is mg sine theta. Force is, what is the force he is going against? mg sine theta. All of you know this, na? The force, I taught you this one. That there are, okay, and length is this much. You know, you have the length. How will you find the length? You have the velocity, you have the time. Convert this into what? 60. Convert into seconds. Okay, then what can you do? Force into distance by time taken. Or if you can do force into velocity as well. Force into velocity is also what? Power. Completely up to you guys. Which method do you want to do? Online, tumra finish kore amake dao beta. Because I have resumed the recording, so I have decided to use this formula. Power is equal to force into velocity. So when he is running, the only force that is acting against him is the what? mg sine theta. So m, what is m? 80. What is g? 9.81. What is mg sine theta? Theta is 3 degree. Into the velocity. Velocity is 2.5. So you will get your answer. Clear? Clear? Okay, what is this? This is mg sine theta. This is your force, and this is your velocity. Okay, now additional power we got. Suggest why running on a treadmill is easier than running on a racing track. More air. Okay, in treadmill there is no air resistance. Okay, fine. Okay, correct. Now let's see some other questions which is important for me to do with you guys. This I already did with you all. Listen, did I do this? Did I do this in the video online? Please, amake bolo to eta ami korchi video moddhe. Sure. Let me see that. Pause recording. Yes, I did. Eta korso video moddhe korchi ami. Okay, to catch kori. Let me go to the next file then. I'll pause the recording. Let me go to the next file. GCE file. Okay, so there is a question. This is from GCE file. Energy hour practice question. Okay, question 5. They said the photograph shows a wind turbine. Okay, kinetic energy of the wind is transferred to the electrical energy. So you know what is kinetic energy and what is electrical energy by the turbine as the blade what rotates. Now explain why we can say that the wind is doing work on the blade. Why wind is doing work on the blade? Because there is a force acting on the blade and the blade is moving a key distance. Work done is key. Force into distance. That is the reason. Understood? Explain why which question number is this? 5. So let's see question number 5 answer over here. 3, 4, 5. So what they said, wind exerts a force on the blades and energy is transferred from, okay, blade moves, okay, through a distance in the direction of force. Typical definition of work done. The area swept out by one blade as it turns 360 degrees. So the area, so 360 degree is around 6,000 meters square. Okay. Wind at a speed of 9 meters per second. At a speed of, and what speed is he moving? At a speed of 9 meters per second passes the turbine. So there is a wind 9 meters per second passes the key turbine. Clear? Show that the volume of the air passing through the area in 5 seconds. Okay, through the area in 5 seconds is about 300,000 meter cube. Very commonly asked question, by the way. Okay, so how do you do this? So you know volume is area. Volume is area into length. All of you know this, na? Area into length. Pi r square h. Remember, cross sectional area into height. Same thing. Area into length is what? Volume. Okay. Now, how much is it going? How much is it going? 9 meters every second. So in 5 meters, how much will it go? 45 meters. If it is going 9 meters in 1 second, so in 5 seconds, how much will it go? 45. 45 meter. How will you find that? Speed is equal to distance by time taken. Speed is what? 9. Time taken is 5. So that's your distance. What is the length? What's your length? 45 meter. So length is 45 meter. Now, what is the area? 6,000. Okay. And how much length of air is there? 45. Understood? So how much is it? Check. 45 into 6,000.
270,000.
270,000 meter cube is the answer, which is close to 300,000. Online, everyone understood that area into length concept you guys are supposed to know. At what speed is the air going in? So it is 9 meters per second. Every second 9 meters. So in total 5 seconds, how many meter of air must have gone in? 45 meter of air must have gone in. Okay. So area is 6,000 into 45. Area into length is volume of the air passed through. Online, everyone understood? Guys, clear?
Yeah.
Okay.
Yeah.
Okay. Now calculate the mass of the air. We know density, we know the volume. Density is equal to mass by volume. So density is 1.2 kg. Mass janina, volume hoche 270,000. You can do this after this on your own. Mass. Oh, yeah, fine. How much is it? Bolo.
324,000
324,000. Sure? 324,000 kg. Now they said, what is the kinetic energy? So kinetic energy is half mv square. Kinetic energy is half m. Mass is 324,000 and velocity upore koto 9. Was it 9? Half 9 mv square.
45.
It was 9. They said velocity 9. Okay, do this in your calculator. Check what is the answer you guys are getting. Comment.
मेरा ब्लूटूथ पे गाना कौन छोड़ दिया है जैसे
Wait, मैं बोलता हूँ. Okay, what is the answer?
13122
13122
000.
000. ठीक है शवल?
Check करो.
बुझ्छौ? Okay, chalo now.
Check करो এটা.
Let's talk about Bed's law. Okay, let's talk. You want to see the answer? 13122 000. Fine. Bed's law states that turbine cannot usefully transfer more than 59% of its kinetic energy to the wind of the wind. Use this law to find the maximum power output of the wind turbine. Maximum power output of the wind turbine. পুরো টাইমটা আমাকে দেয় নাই, ওরা শুধু আমাকে কি দিছে? কাইনেটিক এনার্জি দিছে। আচ্ছা তোমরা একটা কাজ করো, 59% ফাইন্ড করো, শুধু 59% of that. Okay, so output efficiency is percentage efficiency is okay, out divide by in into 100. So out কত?
Find করতে হবে.
Out হচ্ছে we don't know. Okay, in হচ্ছে 13322. What was it? 13122 000. 13122 000 into output divided by input into 100 is equal to 59. Karo. Check karo how much is it, you guys are getting. 59 divided by 100 into 13122 000. 59 divided by 100. Bolo, what is the answer?
77419.
Okay, 77419 1 second per second. Divide by 1 second, na, so that is the power. Because this is the energy divided by power na 77149. Acha eta 5 second e geche ota. Power egulo 5 second e geche. Do we know that this thing over here, right? Okay, 270,000 na. Here we got the what? Mass. Okay, this much. Okay, oh yeah. This much mass of air is going in. This much mass of air is going in 5 seconds. So this much energy was gained in 5 seconds. So this much power. What is the power you guys are getting? Power output kato?
77419.
77419.8. Eta koto second hoise? 5 seconds. So divide by 5. Now this will give you the power. How much is it? It's 1.548 megawatt. 1.548 mega. Mega is 10 to the power 6, na? How much we are getting? 15483 joules, na?
Yeah.
So mega ki power
Watts,
1 watts, na? So 1, 2, 3,
0.96.
4. No, it doesn't matter, na? 0.96 kilo. 84 hobe. How did they get mega over here? That's what I want to know. 7741980. 7741980. तुम्हें decimal क्या ना बोल सकता हूँ? There is some mistake over here. 41980 होगा क्या? Check करो. It please 59% of that. Check half of this almost. 40%. हाँ, not 40%. 41. Double check this one. 59 divided by 100 into 1312200. 77 like this. So
159% or 59.
It is 59. Money can multiply by 100. This is money 59.
Okay.
What did you do? 0.59 use course.
Percent is 7741980.
980. Okay, divided by 5. So you are getting 1.58 megajoules apparently. 1.58 megajoules. 1.58 megawatt. Sorry. Clear, everyone? Now suggest the reason why not possible to use full transfer. Why? Frictional due to rotating this thing blades. Friction in the motor. Okay, aar ki bolte paro. Drag, air resistance hote pare. When it rotates, drag hote pare to overcome the air resistance. Okay, wind doesn't always blow. Okay, only 59% maximum efficiency. Okay, would need to stop wind entirely. What did they say? Would need to stop. Use this law. Okay. C part. Now we are doing C part. Would need to stop wind entirely. Wind or air still moving. Wind or air still has what? Suggest a reason why it's not possible to usefully transfer. Suggest a limitation of using the wind turbines. The wind does not blow all the time. So that is another one is there. So energy is not always available. I'll pause the recording. I think using wind turbine, okay, wind does not blow all the time. What else? It's very costly. It's very costly to build in the first place. Okay, they said low power output, only 59% efficiency. Okay, now what did they say here? Wind need to stop wind, would need to stop the wind entirely, or wind or air still moving. Oh, okay. They are saying is that basically if you want 100% energy to go to the blades, that means that wind is moving, wind having kinetic energy. So wind should completely stop to transfer all the energy to the blades. But here, after moving through the blade, the wind is also moving. So that means all the energy of the wind did not get transferred to the blades.
Drag should be 0.
Okay. Chalo then next homework hoche tumader. This energy GC file. You guys will, what did I do here, by the way? Yeah, I'm taking tests. I know homework is also there. You guys will do first, first 15 questions over here. One or two questions I did it over here. First 15 questions. Most of them are objective anyway. So do first 15 questions for me and come. Please write down the homework. I'll pause the